Hello and welcome. I'll start with this question. Are you finding that teaching fractions in your classroom is becoming a little bit routine and repetitive? Are you finding using things like fraction walls and pizza fractions and structured and colored number lines, the students still aren't grasping the concept of fractions and are making a lot of mistakes in their working? Well, this talk is going to focus on some of those misconceptions. It's going to show you a couple of new ways to teach fractions, and we're definitely going to outline the pedagogical content knowledge and why it's important for teachers to have this and able to teach fractions effectively. So as we said, this presentation is going to focus on the number line and, in more important, location of fractions on it and its density. So I'll pose to you this scenario. This is an exam response from a student who was asked to place negative 0.2 and 1/3 on the number line below, and as you can see, they've placed 1/3 in the incorrect position to the left of 0. So we'll keep this in mind as we go throughout the presentation. In this presentation, we're going to look at the concept of this exam. We're going to identify the problem and its forms. We're also going to see where the concept fits into the curriculum. We're definitely going to highlight some misconceptions for this issue, and we're going to finish with some new teaching strategies for fractions. So firstly, what is the concept? Well, I believe it's two key concepts. It's the location of fractions on the number line, and in this case, we deal with the unit fraction of 1/3, and it's also the density property of the number line. And when I say this, I mean that between any two numbers, there's an infinite number of numbers. The pedagogical content knowledge of the concept is very important for teachers to know in order to teach the topic effectively. So PCK is broken into three branches. The first one is knowledge of content and students. And teachers require knowledge of common student errors with this type of question. This is developed from content knowledge of the concept of fractions, their relation to integers, and the density property of the number line. Students also get confused with number line features such as the point zero, one-to-one correspondence, and the continuity property. The second branch is knowledge of content and teaching. And teachers must know that these concepts first appear in Year 3 and form a major part of learning of fractions and decimals from Year 3 right through to 7. Now, the third branch is curriculum, and these concepts are hidden in the curriculum and embedded in these other topics. The most important three are the ones highlighted in unit fractions, representing fractions on the number line, and counting using fractions. So let's diagnose the problem. I believe it relates to the proficiency strand of understanding and interpreting the number line with fractions. And as you can see, the student placed 1/3 to the left of 0. They got the decimal correct, but they also had a problem relating fractions to decimals to help them out. Another point is the successor principle, in that integers have a next number in the sequence, but fractions don't. So students can't actually count up in fractions as it has issues with the density property of the number line. So they find things like 1/3 difficult to place, as there's an infinite number of numbers before and after 1/3. This problem can take different forms, such as comparing fractions and integers. The student could have converted the fraction to a decimal or a percentage to help them out, but this again could make further problems if they're not confident with those topics. So we can see where the concept fits into the curriculum. It first appears in Year 3 with representing unit fractions on the number line. By Year 4, students are counting up in thirds, and they're locating these on the number line also. And by Year 5, they're asked to compare and order common unit fractions, which is something that this student would struggle with at the moment with their current level of understanding. So let's go to the misconceptions. I believe the first one has to do with the density between 0 and 1. The student places 1/3 to the left of 0, but they haven't actually realized that they've called 1/3 negative by doing this. So they believe that 1/3 doesn't exist between 0 and 1. The second misconception is they think that 1/3 is therefore not a number. So whole numbers are numbers, but fractions are something different, is what they think. In saying this, if you gave a student something like 1 2/5, a mixed number, they can see the whole part of that, and it gives them an area to look on the number line. So a study shows that if we put 0 and 1/3, the correct answer increases from students. The third misconception is a little bit different in that they may have disregarded -1, 0, and 1 on the number line and just seen the line segment and broken that into 3 equal pieces. And the fourth misconception, as we said before, relates to the successor principle, where there is an infinite number of fractions between successive integers, in this case 0 and 1. This concept is very important in high school maths, as in Year 7 they progress from the number line in 1 dimension to a Cartesian plane in 2 dimensions. By Year 9 they're sketching graphs on Cartesian planes, and by Year 10 they're solving simultaneous equations graphically, which means they need to have accurate knowledge of points as well as estimation of points as well. So with all this in mind, a teaching strategy that I would use to strengthen the concept of fractions on the number line with students has to do with fraction towers. So if I get up to the whiteboard to demonstrate, the first thing that I would do would be to use the 1 whole fraction tower, and I would get students in their books to mark out 1 whole and get it to go from 0 to 1. I will then show them that these 2 towers are of equal height, but this one can be broken into thirds. So I'd get the thirds and they would mark that on their number line as well. This can be progressed to 2/3 and so on. Now the benefit in using this concrete activity is that it focuses on unit fractions between 0 and 1. So it's concept specific to that exam problem they had, and because it's concrete, hopefully it will relate to the pictorial type question, which is what the exam is. The second activity would be a more concrete one again. I would get students to stand on the ground and walk out a number line. So with a piece of chalk, I would get them to take the biggest step that they can and mark a 1. They could then mark out a full number line forwards and backwards. The next thing I would get them to do is to come back to the origin and tell them to take 2 even steps to make up that big first one, and there you get your halves. If you then told them to take 3 even steps to make up that first big one, there's your thirds. So again, it's just another concrete example of getting them to create a number line involving fractions. So I hope this talk has outlined some student misconceptions with fractions, some new teaching strategies with fractions, and also outlined how important PCK is for teachers to be able to analyze a concept and then teach it effectively. Thank you.